A little bit few more words context. I'm from the Multimedia Communications Lab at TU Darmstadt, and they're from the Serious Gaming Group. I've just come here from another conference that we organized, the Game Days, in conjunction with Edutainment 2012. And so it's quite soothing for me today to be at a conference and not be responsible for things that are happening here, just for my own presentation. In our group, the Serious Game Group, we are working on serious games in general, so not only educational games but also Excel games and other lines of research. And one thing that unifies our work is that we are working on an offering tool for serious games that we also applied especially to digital educational games, and this offering tool is called StoryTech, which I will present to you today. So I'll give you some motivation first. The topic today will be offering of adaptive educational games, so I will motivate that a little bit. Then go into the concept of this offering tool, especially game content model it is based upon, and then an implementation and evaluation of the tool. So to motivate the topic here, adaptive digital educational games, I brought an example. These are screenshots from a game we were involved in. It was developed in the course of the European Union funded project 80 Days and was an adaptive educational game for learning about geography. So digital educational games have several positive properties. I'm sure all the people in here know about these. So we have a low threshold for learners to come in. They are in here. And if we take adaptivity on top of that, so we adapt game parameters to the players during runtime, we get some more advantages. So we can adapt, for example, towards play preferences, if somebody wants a lot of action or a lot of dialogue. And also, especially in educational games, we can adapt to the previous knowledge the player brings into the game and keep them always in their zone where they can learn optimally, so they are not too much strained, but also not bored. And in this game, 80 Days, we have two major examples for this. We have had adaptive interventions. These were really small-scale adaptive items where a virtual character would give some remark or hint or motivation based on the current of the player. And we also had something larger, which we will also see in the presentation later on in StoryTech, adaptive sequencing, where we choose different paths through the game based on the current state of the game and of the player. Now, the main focus of the talk is not adaptive educational games, but the offering for these adaptive educational games. And this is motivated by looking at how normal game development, especially in serious games, is carried out. So we have a lot of involved groups. We have musicians, game programmers, and so on. We have game designers, artists, and also for a serious game, for an educational game, we have domain experts, pedagogues, teachers, people who know the domain for which the game is made. And this results in some challenges. There's usually kind of break between the technical side and the artistic side and the domain, the specific domain of the game, which can lead to extra time required to finish the game, extra resources, which conflicts with the reality that serious games and educational games usually have a lower budget than entertainment games. So we find that a lot of the people involved in game development are no game experts, so a domain expert is not necessarily somebody who is comfortable with games or knows how to produce a game. Also, they are non-programmers. And our vision is to build an integrated authoring tool which maps all of these people in one authoring tool where they can see the whole game and work on it. And so we need to provide for non-programmers in some way. And an important aspect when we come to adaptivity, we will see later on how it's realized, but adaptivity usually requires that you add more content to your game to allow the game to be adaptive, so multiple paths through the game, and this can make the game more difficult to author, since we take the structure of a non-adaptive game, and make it adaptive, and it allows more and gets less easy to handle by an author. So concerning the related work, we looked into the existing tools there are, so starting in e-learning or authoring tools, and what we found there is tools, if we try to generalize what they do, we find that they have two major functionalities. They handle for authors. They encapsulate the setting up of a navigational structure. So if we have an e-learning product that's made up of hypertext pages, we can create these. We can create the transitions between these pages in the authoring tool and not have to worry about something like HTML or an HTTP server or something like that. And this technical encapsulation and abstraction for the author is also carried out when we create interactive elements in an e-learning course. So here are two examples for authoring tools in which, in both cases, we created a quiz, and we don't have to put in any JavaScript or anything, but we have fields for the content we want to enter, and all the interactivity, something like adding a JavaScript which handles mouse clicks or drag and drop, something like that, is handled by the authoring tool. These are two important aspects that we want to take with us when we make the jump to authoring for educational games. This is exactly the point which we refer to as templates. So we can have templates for often used structures, and also for interactive elements like these quizzes, and other common things like drag and drop tasks, closes, memory games, things like that. We also find in the existing work on authoring tools, we find a lot of metadata, so SCORM or LOM. And one related work, which is not exactly from e-learning, but is actually also for educational games, for educational adventure games, that's necessary to mention. It's also very good to compare to, is the e-adventure authoring tool, which allows the creation of educational adventure games. So think Monkey Island, just with some support for educational games. And what we see there already is that when we examine it, is that it breaks up this this concept of this navigation structure, but allows some form of programming. And this is something we feel is the main difference we have to account for. One of the main differences in authoring for games, we have games are much more interactive than a typical e-learning product. A lot of things can happen when one clicks on something in a game compared to, for example, a website. And we have to allow for this variability, which is also how we looked at ways how we can allow non-programmers to set up interactive activity in it. So some examples are our natural language programming languages, which have text which looks really close to actual written language. And one second example of this is the Form 7 language, which allows the creation of interactive fiction works, So also kind of picture game, but only text-based. And the games actually look like somebody wrote a description of the game, but it's actually parsable due to the syntax by the program. And therefore it's relatively easy to learn compared to a real programming language. Other approaches, it was mentioned earlier today, also the Scratch language, which is a visual programming language. So one sees the structure of the program in visual form and can manipulate it directly. There's also, by Microsoft, there's Codu Game Lab, which builds on the idea of building programs from small blocks, which are shown visually. And there's also the Storytelling Alice project, which also has such a kind of mixture between natural language and visual programming. To a certain extent, scripting languages like JavaScript at least make it a bit easier than C++, but that's here for Stephen's purpose. So this was the look at the work in Offspring tool. Like I pointed out, there are some differences we have to account for. Mainly these non-programmers that we have to support, the inherent difference between games and other forms of learning programs, and taking the concepts that I just talked about, things like templates, visual programming, and combining them, we have created a concept for Storytech. It is based on a model of game content that we have tried to come up in order to describe several types of games. So as I said, we are not only working on educational games, but also, for example, on games for health, exercise games. So it had to be relatively generic, but also be usable still to describe games and work with games. So we had to come up with a basic unit there. We decided against something like a timeline. Instead, went for the concept of the most basic unit of the game as a scene. If you are now thinking of theater, you are thinking exactly right. So a scene in our model is intended to be a small part of the larger structure of the game, which has a certain unity of the surroundings, the set, the props, characters, and other objects which are in the scene. And so a game can be made up of a lot of these themes which are interconnected. The next set in games that we use in the model are objects. So things like props, characters, and also logical things like variables, which can just be placed inside scenes. These objects can then be parameterized. So we have some core parameters like width and height, which are always or almost always applicable, and some domain specific. So for an Excel game, it could be like something like the heart rate that the player has to achieve. For adaptive educational games, we have a model called referred to as narrative game-based learning object, which I will cover on the next slide. These scenes can be connected to each other. There's a difference. We don't have a list of scenes which follows linearly, but we can have branching structures, so it's just a graph of connected scenes. And such an arrow indicates a connection. These connections can also be free, which means that I don't indicate which scene exactly I want to go to in the game, but I just tell the system at this point, please choose a scene which is optimal for the player at this point in play. So in an educational game, using narrative game-based learning objects, this would mean that the game chooses a scene that fits well to the current knowledge of the player. So it teaches something that is on their learning path at the moment. So this leads to the effect that we don't have a fixed path through the game, but rather an adaptive path. Like I said, based on the notion of narrative game-based learning objects. A narrative game-based learning object refers to a scene which has been, to which metadata has been added concerning narration, player preferences, and learning. The player preferences are based on a player model, which categorizes gamers according to their play preferences. It's exchangeable, but we use the one by Bartle, which uses these 4 categories. And concerning learning, we use the concept of competency-based knowledge space theory, where we model our curriculum in the game as a set of skills which are interconnected with dependencies. So you can have such a structure where you have to understand skill A or competency A before you can learn the others above it. And the adaptation algorithm then chooses, based on this information, chooses the optimal next scene for the game. Adaptation, I also said that the authoring tool uses this concept of templates. We can have things like structural templates, which are things you can load or add to your game, which are like best practices. So in an e-learning task, a very simple structure that is pre-made could be something like this: instructing a task, some feedback, and a conclusion. And we also have interaction templates. These are intended, like the quiz we saw in the e-learning tools, are intended to encapsulate the technical aspects of the game for an author who is a non-programmer, which means the author only gets to edit the most relevant features of the game, the game content, the educational content, and the actual implementation of the gameplay is supplied to the author, because that would be much too complex in a visual programming language and would not be feasible. We, however, allow programming to a certain extent by adding a visual programming language, which is based on the idea of, on the one hand, stimuli, which are events which go from the game to a component which is fed by the authoring tool, which is set up by the author. It informs in the one direction that something important in the game has happened, like the player has finished a task, and on the other hand by actions, which indicate to the game what should happen next. And both are intended to be on a high level of abstraction, so this is nothing concerning move something 5 pixels to the right, but rather player finished a task, or have a virtual character say something, change the scene, award an item to the player, things like that. These actions and stimuli are combined in an action set, which is like a sequence diagram. It can be edited interactively and indicates what should happen in the game whenever a stimulus has been executed, has been perceived by the game. And what it does is do one of these actions after another, and also possibly branch based on the current state of the game using a condition. This is the whole of the model which we use to describe games and work with games. On top of this model, we can build some more functionality. So one thing we've been working on is a dedicated analysis tool, which can be used to capture a playthrough of a player and, for example, record the history of scenes that they have seen, and also those which the algorithm has chosen for the player. So an author can test out the effects of adaptivity in the game, because authors in general are already can already be overburdened by creating a game, and on top of that, creating an adaptive game where they don't have complete control over what happens during runtime can be quite daunting for an author. We also support iterative design, so in using the tool one can relatively quickly, using placeholder content, create a small game, test it in this analysis tool, and use the results from the testing, the insights gained, to create new version of the game and to improve it continuously in that way. This all leads to an overall system for which is here. This is the runtime of the system where the game is played. The main parts to take away here is that we have a separation between the game engine, which handles all the low-level tasks and all the rendering, all the classical game development tasks, and a story engine, which is responsible for managing exactly this game content model that we saw, and which also is responsible for receiving the stimuli from the game and sending the corresponding actions back to the game. The system is implemented as a tool StoryTech. You see a screenshot here. It has four main parts. Stage editor, which is what you see is what you get as a presentation of the game. Story editor, which is concerned with the navigational aspect of the game, so you set up the whole structure of the scenes, transitions, and objects there, and you can also have an overview of the whole game there. Property editor, which, as it hints at, is used to configure the properties and also the metadata of objects and scenes. And an object browser, which has the whole repertoire of objects which can be used in a game, and also all the templates that can be used in a game. These are shown here in detail. So the stage editor is for editing. It has for each kind of interaction template, it allows the author to work with it relatively easy. And all the work configuring the content for the interaction template is done in the background. So if I have a puzzle, for example, I only load one image as the puzzle, and the whole cutting up the image into pieces and the implementation of dragging and dropping and so on is handled by the authoring tool, respectively the game engine later on. As I said, the story editor for editing the structure of the game interactively, the property for setting up these parameters, the action sets, the visual roadmap is realized in an editor that represents this, what we saw earlier as the diagram. So it's like a sequence diagram. One can edit interactively and add actions and conditions. And we also have, for the educational games and the adaptive side, we have a knowledge space editor, which we call it, which is used to set up the skills in our curriculum and the dependencies between the skills. The analysis I talked about is called story play. It has two sides. One is a player for StoryTech games, and the other side is the analysis tool, which shows the background information from the adaptation algorithms, and it can also show or give like a reasoning why a certain scene was chosen at any given point in the game. And this is from the paper. Also, you can have a look there. Also, we try to map, like I said, all the roles we found in game development onto different parts of the authoring tool. Now the last point I want to cover before I finish up the presentation is evaluation. We have carried out several evaluations which has been described in several publications. The first ones were usability studies, where we looked at the usability of StoryTech. Here are some examples from this it's based on the ISO standard for usability. But what we felt was that these studies were hanging a bit in the air. They didn't have a lot of reference to anything else, and mostly helped us versions of Storytech. So what we did next was do a comparison study with the adventure tool I talked about in the related work. So the tools can be used to create similar games, and we constructed a set of tasks that could be done in both authoring tools. They were formulated in such a way that they didn't use any words or concepts from one of the authoring tools, so the tasks were identical. And we gave these tasks to users who hadn't used Storytech before and also e-adventure before, and they were asked to do these tasks and do a questionnaire afterwards. The results of the questionnaire are already evaluated, and we've seen that Storytech is slightly preferred to e-adventure by authors. Rest is in more detail, but we also have what I'm really looking forward to present in the future are the results from looking at the products the authors created. So they had to save their state after each task was completed, and we're going to evaluate the times they required and the quality of the results they made. And now to wrap up, I presented the authoring tool Storytech for adaptive educational games in conjunction with the player Story Play. And this tool is also available on the internet. You can register on the website storytech.de and receive a version for testing. And further work on our side will be the continuing analysis of this comparison study, and we're also working on putting the concept of Storytech into a web-based authoring tool in order to lower the threshold for authors. And with that, I would like to thank you very much for your attention, and I'm ready for your questions.
Thank you very much. You said in the beginning that adaptation that takes place in the game is kind of setting the scene based on knowledge that the game player has. Mm-hmm. And now I wonder in how far is like the story of the game affected by this adaptation, and in how far is it becoming very complex for the author to think of a game story that is still like plausible for the game player when the adaptation is based on knowledge, and there are different models in your model for the knowledge or the user model and the gameplay model. So I wonder whether there is a conflict in adapting the gameplay based on knowledge.
Yes, this is always a question of how exactly one offers the game. In our course, what we use, for example, is that we have a brand structure. We have first some feelings where we kind of assess where the player is currently at. So we give them a task they have to work on, for example. Then we say something like, for example, we should provide the next scene for one of each of these player types. Or also a little bit more, where we have a combination of player types and different knowledge which is imparted. But of course, this adds to the complexity of the offering, and you have to provide more context. Another thing which we have done in other projects was easier. So in the math project we did this. We had a pool of students go into the pool and then select items from there. This is another application of this.
Okay. I don't know. It looks like you are almost at the product stage, right? It is. I was wondering, do you have contact with serious games company that yes, you want to have it or yes?
Actually, we're providing it for testing purposes. The main cooperation with industry is in the form of research projects. So we have several projects where it was used or it's used in the project, and we also have some examples where, for example, together with the city of Darmstadt, we made an advertisement game for them, which was created in Storytech. But we're not selling licenses or something like that at the moment.
So did any company might have interest?
Well, if we go to fairs like the CeBIT, there's sometimes a question, how much would you visit, things like that, so there's interest there, yes. And also we made an evaluation with a game development studio, and they found the state it was in then, they found it very interesting. Of course, it was more typical than it was now, but there's some interest there, yes.